Good morning, students. Now, today in this video, I am going to discuss next topic, that is adsorption isotherm. Isotherm, isotherm means constant temperature. It is clear that this process occurs at constant temperature. That means this adsorption isotherm is explaining what? Adsorption isotherm is actually explaining the amount of gas adsorbed on the surface of solid. Here, suppose this is solid surface, adsorbent is provided, and on this adsorption occurs. So, the rate of adsorption is correlated with pressure. This rate of adsorption is correlated with pressure at constant temperature. That means adsorption isotherm is what? The variation of amount of gas, or we can say the variation of quantity of gas adsorbed on the surface of adsorbent the variation of quantity of gas adsorbed on the surface of adsorbent with pressure at constant temperature expressed by at constant temperature is expressed by adsorption isotherm. So, under this, I'll discuss Freundlich adsorption isotherm. Freundlich adsorption isotherm. Freundlich adsorption isotherm is what? Suppose quantity of gas adsorbed is equals to X, and amount of adsorbent is equals to M. So rate of adsorption, that means the quantity of gas adsorbed per unit mass of adsorbent is directly proportional to the pressure, which has exponent 1 by n. Quantity of gas adsorbed. Quantity of gas adsorbed per unit mass of adsorbent is directly proportional to the pressure, which has power 1 by n. That means it is what? X by m is directly proportional to the pressure, which has power 1 by n. Now this proportionality will be removed by proportionality constant K. So this is x by m is equals to K P to the power 1 by n. Now here I am going to tell you how we can express K and 1 by n. So where K and n are dependent on the nature of adsorbate and the gaseous particles adsorbed. Gaseous particles adsorbed. Now here this is n. N is always greater than 1. N is always greater than 1. It is not less than 1. And the validity of 1 by n, that means it ranges between 0 to 1. 1 by n ranges between 0 to 1, and most probable value is 0.1 to 0.5. This is most probable value for 1 by n. Now through graph, its validity means validity of Freundlich adsorption isotherm is dependent on the graph. So first of all, we'll try to understand it through graph. When temperature varies, then what type of graph we are getting? Just try to understand it through variation of temperature. Through variation of temperature, I am going to explain it. So here actually this is y is equals to mx plus c. So y we are taking what? X by m. That means the quantity of gas adsorbed per unit mass of adsorbent. And this part is taken pressure pressure we are taking as x-axis, is it? And under that we are observing what type of graph we will get. When temperature varies, so this is x by m and this is pressure. So suppose T1 temperature is lower temperature and T2 is higher temperature. T2 is higher temperature. So what type of graph we are getting? We are getting this graph. This graph is for suppose T1, then another one graph is for T2. This is another one graph. This graph is for T2. That means through this graph, it is clear that higher the temperature, rate of adsorption will be lower. So through this graph, variation of rate of adsorption is expressed by increasing temperature. And it is clear that by increasing temperature, rate of adsorption decreases. That means rate of adsorption is inversely proportional to temperature. Now, I am going to convert it in logarithmic term, and through logarithmic term, we'll discuss again next graph for Freundlich adsorption isotherm, which validate this equation. So, as I taught this one, x by m is equals to k p to the power 1 by n. So, we'll apply log on this equation. On this equation, on equation 1, we will apply log. So apply logarithm, apply logarithm on equation 1. So equation 1 was x by m, is it? X by m, so it will be log x by m, and opposite side also I am taking log. It was what? K p to the power 1 by n. So already in class 11th I had discussed about log, how to apply log. So this is log x by m, log k plus, this is exponent, so 1 by n log p. Now through this we'll try to make graph, and for this we'll use graphical representation equation. This is what? Y. This is y. Here there is two terms. So this is mx plus c. So y is log x by m. C is log k. C is intercept. M is slope. Slope is 1 by n. And x is log p. Now through this we are going to make a graph. Now here this is positive term. So intercept will be downward, and that means graph will be not started from initial point. Y-axis is log x by m. This is y-axis, and x-axis is log p. And we are getting this graph which is expressed experimentally also. It is explained experimentally also. So intercept is log k and slope is 1 by n. On tangent here slope is 1 by n. Slope is equals to 1 by n. So through this graph, through such type of graph which we are observing experimentally, it will be validated that through Freundlich adsorption isotherm, whatever equation we are getting, this is correct or not. So it is proved by graphical representation. Now, as we know, by increasing pressure, at high pressure, adsorption process increases, but at lower pressure, adsorption process is less. So initially, when we are increasing pressure, in that case, it will be observed rate of adsorption will increase. But when after a certain period of time, by increasing pressure also, adsorption process will be constant, that is saturation pressure. And adsorption isotherm, that means Freundlich adsorption isotherm, was failed to explain it, that this was the failure of Freundlich adsorption isotherm. He explained that terms, two conditions he discussed, but through graph he was failed to explain it. So that two terms what he discussed, if 1 by n is equals to 0. And now we are applying this on equation 1. Now we are applying this value in equation 1. So x by m is equals to k p to the power 1 by m. So to p to the power 0. That means x by m is constant. And this condition is observed at high pressure. This condition is observed at high pressure, but Freundlich adsorption isotherm explained this equation or this process, but he was failed to explain it experimentally. Now, if 1 by n is equals to 1, so this is what x by m is equals to k p to the power 1 by n. So this is 1, and this process occurs at low pressure. Low pressure, when we are increasing pressure initially at that time. So here rate of adsorption, rate of adsorption is constant. Rate of adsorption is constant, and which is called saturation pressure. That pressure is called saturation pressure, from where rate of adsorption trying to become constant. And here we are observing what? When initially pressure increases at low pressure, initially we observed rate of adsorption increases, rate of adsorption increases directly with increase in pressure. With increase in pressure. So its graphical representation I am going to explain. Its graphical representation is here. This is x by m, rate of adsorption, and here this is pressure. And now we are going to explain this graph. So this is low pressure. At low pressure, we are observing what over here? X by m is equals to Kp, and it is low pressure, and this is saturation pressure where it has become constant. So x by m is equals to K at high pressure, and this is called saturation pressure. Saturation pressure. So that Freundlich was not able to explain it experimentally, and this was the failure of Freundlich adsorption isotherm. So today I discussed about Freundlich adsorption isotherm. Now in next class I will discuss about adsorption in solution phase, and again type of adsorption. It is in terms of homogeneous catalysis, heterogeneous catalysis, even catalysis also. Okay, for today this much is enough. Thank you.